Hi, this is Mingyao, and in this video I'll be going over how to model welds in Ansys Mechanical. We can start with looking at geometry, and this showcases some of the capabilities of modeling seam welds specifically. For seam welds, we're going to turn all of the parts into shells. The seam weld simulation in Ansys Mechanical is based off the Volvo-Chalmers method. This can integrate with nCode to help you understand the fatigue and durability of your welds. Let's first split this part in two. So we're going to go do design split body by this face. Then we're going to mid surface automatically. And now we have a little gap between it. So we're going to weld this plate down to the bottom here, as well as this flat plate onto the bottom. Let's go ahead and give it a try. We're going to start with a static structural analysis. Okay. The weld modeling options are under meshing. There are some weld options here. First thing we want to do is turn off adaptive, which is already turned off here. So if this is set to yes, we need to make sure this is set to no. Then we want to start adding some welds. So we'll do one first. We're going to do a continuous seam weld. You have the option of doing intermittent seam weld as well. We're going to create this using edges, and I'm going to select this edge. Let's go ahead and generate a mesh and see what it looks like. Right, so we didn't create this because there's another control we have to turn on. Batch connections needs to be yes. And we can leave all the rest of it as default. And what this means is that it's going to try to connect it afterwards. There are a number of options inside of the weld. So for example, one of the things we want to be careful about is the heat affected zone distance. And this heat affected zone is when you weld it, how much is the heat affected zone. So we're gonna, 33 is fairly large, so we're gonna change this to probably, let's say 5 millimeters. We can also, the weld here actually, if I turn it over here, the weld probably spans an angle like this. So what we can do is we can adjust the height of the weld. So you can adjust the height on either side of the weld. There's a adjust height. There's the two legs. So maybe we do 2.5 on one side and 5 millimeters on the other side. Oh, and let's adjust the edge to 20, something like that. Okay, you can see that we've generated a mesh. Right now this is a normal weld, so it just goes down here. You can see there's 2.5 millimeters up here, and there's 5 millimeters down. What we can also do to adjust this weld is, instead of the normal weld, we can do normal and angled, and we can select the angle direction to both. We can also select the material. So right now I'm just going to pick structural steel, but we can pick other material if needed. All right, so this shows you the shape of the weld that we're going to generate. And this is all done automatically, so now we can do an analysis based on this model. We can increase the number of elements in the heat affected zone as well. So you can, right now, the number of heat affected zone is just 1. So I'm going to bump it up to 2. And you can take a look at, now there's 2 layers of heat affected zone coming off of the weld. So depending on the accuracy you want, you can see the mesh is very careful here. Okay, now let's add the weld into for this plate. I'm going to select this one side and insert a weld, and we'll do a normal and angled weld, and here do a heat effective zone of 5 millimeters, and we can adjust the. Right now the criteria is width based. We can also do angle based, and this allows us to do maybe a 60-degree weld. Okay, the mesh doesn't look all that great, so let's we can also, instead of using edges, we can use edges in face. So this is the bottom surface, and then this is the top surface. Let's try 45-degree. Okay, there you go. So a 45-degree weld seems to work okay, and we can do a similar thing on this side. I can just duplicate this and pick this edge. Okay. Now let's add in some supports. Let's put a fixed support here too, and let's put a force upwards in the y-axis. Oh, I have a few parts that we didn't assign material for, so these should be weld properties, but I just went ahead with structural steel here. In the nCode tool set, we have some weld material information for fatigue as well as stiffness properties, so we can use that if you have the nCode package. Take a look at the deformation. Take a look at the stress. Okay. We can see where the high stress regions are, and now we can do a fatigue analysis. So let's go back to Workbench, and let's put in a nCode, the built-in nCode fatigue calculation. Let's see, I think it's an ACT extension right now. Mechanical embedded. I think this is a mechanical embedded nCode. Okay, once I installed the nCode embedded design life, I had to start it up again, and now I see the nCode design mechanically embedded design life option. So let's go ahead and get it connected and take a look at the setup for the weld fatigue calculations. So we can do shell seam weld analysis, load mapper, okay, I want a constant amplitude, still have to do the static structural, and I think what the message is saying here is that we must solve the structural with nodal forces turned on. So let's go back here, output, turn nodal forces to on. And now let's clear the generated data. The other thing I adjusted was in the welds. We want to generate name selection. So it's creating name selections when we run the simulation with each of the welds defined, the weld elements. Let's go ahead and run the solve. Okay, it's done. Okay, so it's running the simulation now, and it's completed, so we can look at life. So there's plenty of life here, over 1 million. Now we're going to adjust our maximum factor, increase by 100 times. Okay. So now we see that the failure point, as we expect, is here on either corner. It's showing us the heat affected zone of the weld and what the durability is at each location. So this shows you the ability in Ansys to create different types of seam weld geometry. It's highly automated for shell models, so the geometry can be created during the meshing process itself. We have a variety of controls for the angle as well as the distribution of the welds. We can look at structural analysis and use specific weld patterns to capture the stiffness and the connection between the different parts. Look at the stress, and we can also evaluate design life, a weld, a specific shell seam weld analysis, and look at the life of our weld. So that's a quick overview of how to set up welds in Ansys Mechanical. And thank you for your interest in this video. If you like videos like this, please subscribe to our YouTube channel. And thank you and have a good day. Bye-bye.